chains, webs, and pyramids. Lesson 2 for ecology. You're going to need to know how to make a food web and order a feeding level. Tell me the difference between consumers and producers. And importantly, use a food chain or web to explain how disruptions can spread. And then look at the value of the pyramids of numbers, biomass, and energy. And I want you to be able to quantitatively, that is with numbers, explain how energy decays in the ecosystem and how you see that in your examination of a natural environment and the number of critters you find at each level. Food webs and chains are very simple at the start. What we do is we order animals by their trophic level. That means how far up the food chain are they? Trophic level 1 starts with your plants. Trophic level 2 is the things that feed off of plants. These are called producers or autotrophs, and everything that needs another life form to eat is called a consumer. Herbivore if it only eats plants, carnivore and omnivore if it eats both. Decomposers, like our hungry little earthworm here, are never put on the food chain for the most part because they connect to everything. And so they'll really mess up a food chain. But in the end, they get every one of these critters. So the worms really rule the earth. Ecologists sometimes start the numbering from the animals. So you got to pay really close attention to questions on textbooks and on tests. Do they say start numbering from the consumers, or do they start numbering from the bottom trophic level? So the grasshopper is a first consumer, which is a herbivore, but it's also at the second trophic level. It's an annoying distinction, but it's not something that requires a lot of memorization and thought. Just pay attention where the numbering is started from. And the word third can be called tertiary and fourth quaternary. I don't use it, the textbook does. All a food web does is put it together as a braid, indicating every food source an animal has, not just one. So this python here is feeding on 3 different creatures, while the eagle has a very rich diet of 5. The rat has a serious problem in this environment. He only eats grasshopper. If you wipe out the grasshopper, the rat's done for. The eagle would be much harder to completely wipe out. Now, if we eliminate the python, what do you think would happen? Well, your first thought might be, wow, we're going to get a lot of rats. But if we get a lot of rats, the eagles may eat them all. But if we get a lot of rats, the number of grasshoppers may fall, and the rats could starve to death. And if that happens, then the eagle loses 2 of its food supplies now. The pythons we killed and the rats who disappeared. This means it might turn to eating more frogs, but the frogs have already lost some of their supply. It might switch to eating more thrush, which would cause the fruit flies. It's really hard to decide what's going to happen. But if you start at the bottom, the effects are considerably more catastrophic. Okay? If you wipe out the corn, the grasshopper's finished, so is the rat. And the frog is compromised. And you can follow it through, and the effects can be quite dramatic as to what happens if you disrupt a food web. And we're going to spend a lot of time looking on real world cases where this was done. And it seemed like an easy solution at first, but it caused disastrous consequences by tampering with it. One of the ones we'll study is what happened when wolves were taken out and reintroduced into Yellowstone. And we have a couple videos to look at it. The main purpose, though, of a food web really is to demonstrate interconnectedness. And the concept of the tree of life is found in every society ever studied, that we realize on sort of a spiritual or mystic level that we are all tied together in some great web of life. All the scientist is doing is adding another layer to the sense of awe by demonstrating it quantitatively in a manner that everyone would agree on. There's no question once you've studied it that you've got the right answer. The tree of life is found in Norse mythology. I won't even try to say Yggdrasil, even though I just did. You see the tree of life here in ancient Sweden, all the way over to Iran 3,000 years ago. Here's a gold tree of life depicted. And speaking of gold tree of lives, the movie The Fountain a few years ago with Hugh Jackman playing a decidedly unWolverine character. The tree of life figures prominently even in the woman's dress, and it's controversial film. It's got some beautiful film scenes, and if you've ever lost anyone, particularly to cancer, you won't get through the film without weeping. But this is his spaceship at the top of the page throughout the movie, which is kind of really neat. Here is some modern native art trying to show this idea of interconnectedness, and a very famous poem by Francis Thompson that covers the same topic. And this is what I mean about scientists working on it. This is the Tree of Life. It's an interactive one on Evogeneo website, and it allows you to click on all the known species we've indexed. So you can zoom in on this thing for quite some detail. This is not part of grade 9 ecology. That's later in high school. And here is a modern food web made by scientists today. So the ones we do in school are quite simplified. This one here is northern cod only, and it's a partial food web. This one on the left is a modern virtual reality food web. You can put on an Oculus helmet and fly through the food web, look at chains. These are all databases that hundreds of scientists contribute to. So anytime a person, particularly a politician, goes, well, we should go back out there and fish for more cod. What's the big deal? No, the complexity of the natural food webs, we have never totally figured them out yet. And anyone who says we have doesn't know what they're talking about. So if you're interested in what modern ecologists do, it's considerably more advanced than what's in your textbook. Next, we're going to look at ecological pyramids, but I'm going to break that into lesson 2B.